Good. Our two solutions are 5 and -3. And did they check out? Oh, yes, they did. So they are two real solutions. Now, the next question, what changed? Right. It transferred from being an equation to being an inequality. It went to be an inequality. Now, let's solve this over to the side. So I want you to rewrite it. For absolute value x minus 1 plus 3 is greater than 19. Do you think at this point we can go ahead and solve this? I mean, we can split it. What do we need to do first? Perfect, just like we did with the equation, right? So we have 4x minus 1 equal, oh gosh, is greater than 16. Then we divide by 4. Now, do I flip the sign? No, because it is not a -4. So that's what I have so far. Looking at this, how many boundary points am I going to have? Right. So another word for a solution is a boundary point. It just, when you're dealing with inequalities, it's going to be a point on your number line. So here, because it is a +4, you have 2 boundary points. So now it's asking, what are the boundary points? That just wants us now to solve this. So what do I do from here? Now I split it. I'm going to run out of room, so I'm going to do it next to x minus 1 is greater than 4, and x minus 1, and I have to make that 4 a what? What else do you think I'm going to do here? I have to flip the sign. So it was a greater than symbol. It now needs to be a less than symbol. Always flip the sign on that negative. And if you think you're the type that's going to forget that, make a little note. Flip the inequality. All right, now we solve. I add 1 over. X is greater than 5. Add 1 over. X is less than -3. Same numbers as we had before. Instead of checking them like we did in the equations, you have to do something different. So here it says, should the boundary points be marked with filled or unfilled circles? Why unfilled? Unfilled because the boundary points are not equal to. So now whenever we have inequality, absolute value inequalities, you have to graph them on a number line. So where do you think I'm going to put that x is greater than 5? What do I do with that? Oh, you put an open or closed circle on 5. Perfect. And it says greater than 5. So which way am I going to shade? Good. In the positive direction. And then we have x is less than -3, so I'm going to put an open or closed circle. And then which way am I going to shade? Right, in the negative direction. So is it a little more clear why these points are called boundary points? Right, it literally sets the boundary on your number line. How many different regions do you have here? 3. There are 3 regions, meaning that in order to check our answer, we need to check all 3 regions. So here it says, how many regions do you need to test? All 3. And you test it the same way by plugging in a number to your original inequality. But are we going to plug in -3? You're going to plug in some other number in this region. Yes, Grace?
I want to know what the regions are.
Oh, I'm so sorry. Okay, this is your first region. This is your second region. And this is your third, right? We have shaded on the left-hand side of the boundary point. We don't have shaded between them. And we have shaded on the right-hand side. So there are 3 boundaries, to the left, to the right, and between. So how you test it is you pull any number from this first region. So somebody give me a number. -7. Okay, we can do -7. So 4, and then I'm going to put in -7. So then we have -7 minus 1 is -8. What is the absolute value of -8? Which is, what's 4 times 8? Plus 3? Is 35 greater than 19? That boundary point worked. And it should work. Don't I have this shaded? Yes, so I have this correctly shaded. Now we check the second region. Pick a number. 0 is most likely the easiest number you're going to come across. So 4, oh, that's thick. 4, absolute value, 0 minus 1 plus 3. So 0 minus 1 is -1. The absolute value of -1 is 1. 4 times 1 is 4 plus 3 is what? Is 7 greater than 19? No. And we didn't want that to work out. Right? We didn't have it shaded, so we were correct here. And last region, third region, pick a number. 6. So 6 minus 1 is 5. The absolute value of 5 is 5. 4 times 5 is 20. 20 plus 3 is 23. Is 23 greater than 19? So we have everything shaded correctly here. Sometimes, after you do all this, you're going to find that a section that you didn't shade actually should be shaded. If this happens, so you already had the outside shaded, you tested the middle, and it is true, it means that your solution is all real numbers. Everything should be shaded. That's why we have to check the regions, because algebraically may give you something different than your true answer. Sometimes none of the regions could work, and then it could be no solution. All right. And then what is the solution algebraically? All you have to do is list out the solutions. So x is less than -3 and x is greater than 5. That's all that means. Did I just confuse the heck out of anybody? Okay, great. So go ahead and do the back.
I'm like,